All right, guys, for slide 6, you can see that there's 4 here that I've named. Those are drawing practice, so I'm gonna kind of zoom by those on the notes, and there's some you can name that I've drawn. So we're gonna go right to slide 7, solubility. If there are 5 or fewer carbons for an aldehyde or ketone, it will dissolve in water. So 5 is that number, we're still there. If there are 6 or more carbons, this is a ratio, then it's gonna dissolve in a nonpolar solvent or fat. Generally speaking, aldehydes and ketones have higher boiling points than alkanes, but lower boiling points than alcohols. So there's our change. Showing you a couple right now. So what acetone and progesterone, what are they going to dissolve in? Well, acetone has a carbonyl group and 3 carbons, so this will dissolve in water. Progesterone has 2 carbonyl groups. There are 2 ketones here, but there's also a lot of carbons here, so this is going to be fat soluble. It's not going to dissolve in water. Down here, rank the following in order of increasing boiling points. So we're going to start with the lowest. What's going to have the lowest boiling point here? Well, that's going to be hexane, because that's the alkane. Number 2 on this list is going to be pentanal, and then the highest boiling point is going to be pentanol. All right, so there's our boiling points. Here's just some common aldehydes and ketones. Formaldehyde, as you know, acetone, nail polish remover. And then a lot of them are in sunless tanning and sunscreen. So dihydroxyacetone, this is like fake. You rub this on, you get tan. All right, so it's fake tanner. Uh, avobenzone, oxybenzone, and dioxybenzone. Those are all in sunscreen, the non-mineral based kind. And then aldehydes generally have a smell to them. So a lot of these scents that you pick up, you're going to smell aldehydes. Like we know what cinnamon smells like. That's cinnamaldehyde. I guess that's cinnamony smell. Vanillin, this is an aldehyde that is in vanilla, and actually we smell that compound in the lowest concentration of anything. So that's why we like vanilla. And then this is citronellal. Um, here's our al, why the ending is what it is, and that's the lemon scent in citronella. Okay, reactions. This is going to be kind of a big slide, so hopefully you'll pay attention here. Oxidation. When something is oxidized, you're adding oxygen or removing hydrogen. It could be either. So aldehydes will get oxidized, just this little O, into carboxylic acids here. Ketones will get oxidized into nothing. No reaction occurs. You cannot oxidize them. All right, we'll get to that Tollens in a moment. So here, if we have an aldehyde and we oxidize it, it becomes a carboxylic acid. Easy. You should be able to do this one and this one. I don't think those are very difficult. Reduction is the addition of hydrogen or the removal of oxygen. It can be either. Usually it's written as with this H in brackets. So a aldehyde gets reduced to an alcohol. It actually becomes a primary alcohol. A ketone gets reduced to a secondary alcohol. All right, so here, this is an aldehyde. We'll get a primary alcohol, secondary, 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 primary. All right. Now, Tollens reagents, if you remember chapter on alcohols, those OH groups, those can be oxidized as well. Tollens reagent, if you have an alcohol group and an aldehyde, selectively oxidizes the aldehyde group. So we can pick and choose what we're going to do. And that's it. You do not have to memorize this formula, but needed. I would write Tollens over the reaction arrow like this, and we'll oxidize that aldehyde and we get our carboxylic acid. You should be able to do that with this one right here.